So today we are going to cover SSL and TLS on a very basic level. As our panelists said, security is everybody's responsibility. So often we see from a DevOps perspective that whenever there's a question or any error around SSL or TLS, there's a quick email drop to DevOps. Please help on that. So what we are trying to do today is, we start from basics of encryption, SSL and TLS, and go to a intermediate level, so that everybody, even QA team, PM team, is aware and is aware of the complex terms that are being used there, right? So let's start right, and then let's see where we start from the encryption's basic. So yeah, on the screen you see a very lame, a very basic cryptography algorithm, right? So on the left you see there's a ROT13. This is basically rotation 13, right? If you cipher alphabets and replace them with the 13th alphabet, then hello becomes something else, right? So this is the very, very basic of cryptography: how to change, how to encrypt your message, original message, right? Here substitution was being used, but complex algorithm, the modern algorithm, have a lot of formulas and algorithm underlying it. So a lot of mathematical calculations goes underneath, and you don't know. So these are not as simple as ROT13, but a lot more complex. The whole point of encryption is to avoid eavesdropping, right? So nobody in the middle of the conversation should be able to read the message, right? So that's encryption. Now, one important thing to understand here is the difference between encoding, encryption, and hashing, right? So encryption, as we talked, just to avoid eavesdropping, right? Encoding is a term that we often come across, but often get confused between encryption and encoding. So encoding is nothing but a very simple mathematical formula just to change the way message looks. It's like, the same message in Hindi or English language would look different, but the message is same, right? And you can easily, if somebody knows how to translate that, then you can read that. But encryption requires a lot more complex mathematical calculations and algorithm to change the way message looks and being read. Right? Hashing is just one way of sending data. It's irreversible. Cannot undo the hash, right? So you have a certain key or number and your message. You do some mathematical calculation and come up with a hash, with a digest, right? So this mathematical calculation is hashing, and the outcome is digest. So these three terms get often confusing, but these three things are different altogether. But today we are going to focus on encryption, because TLS and SSL relies on encryption altogether. There are two types of encryptions, symmetric and asymmetric. On the left side you see, right? So its process is almost same. As I said, eavesdropping is the problem we want to solve with encryption. So you see original text, and a key, secret key is being used to encrypt and transfer, and the same key is being used to decrypt the data. Now, encrypt and decrypt is happening through the same secret key. But asymmetric encryption, which is more complex, slower to do, but more secure, is where you have two keys, public and private, right? So as the name suggests, public is the one that is available with everybody. Private is the one that only servers, only the person who sends the message. In this case, Facebook, let's say, every server you try to hit from a web browser. So that has private key, and that requires a complex infrastructure to manage private key to keep it secure. But public key is available with everybody, right? So encryption happens with public key, decryption happens with private key. Now I get this question often, and there are a lot of threads around it. Can we do encryption with private key? Technically, yes, a private key is fully capable of doing encryption. But in the TLS SSL model, it is not required. It doesn't do. It can, but it doesn't do in the whole process, right? So private key can encrypt, but it doesn't, right? So that's symmetric and asymmetric encryption. So we will just talk about asymmetric encryption because that's where SSL is based on. Now, how did it evolve? Now, earlier in 80s, right? So client server model used to work on HTTP protocol, which is how the client and server sends message in a reliable way. Reliable means no packet of information gets dropped, right? So that's HTTP. Now, Netscape Navigator was a browser. Netscape was a company and Navigator was a browser. They said, I will change the scenario. I will bring in encryption on top of that. That HTTPS was brought in by Netscape Navigator. Many white papers, RFCs went in, and SSL was born, SSL 1.0. So it became HTTPS. Now, as SSL evolved, it went to 3.0 version with multiple modification. But Internet Engineering Task Force said, SSL has some issues, and it really, was evident from many attacks. So this way, TLS was born. TLS is nothing majorly different from SSL, but it is more secure. Let's say there are some complexity underlying, like the way it talks to port, the number of port that are open during the handshake process and initiation. But TLS is more secure. Right now, TLS 1.3 is the thing. Okay, so SSL 3.0 was the last version, and many new browsers are thinking to deprecate SSL completely. Most of browsers have already done it, right? So that's the evolution. So if somebody asks TLS SSL, it's just TLS is based on SSL, a little more secure, right? That's a comfort answer. So here you would have seen a lot of icons in your browser, right? So let's say you open Chrome and hit facebook.com, right? So and any URL, let's say. Now you would have seen these three kind of icon on the browser, right? So this means secure. SSL is verified, and everything is fine. This means that it is HTTP, and I'm not sure is it encrypted or not. So I don't suggest. This red triangle would mean this is pretending to be somebody internet doesn't know, right? So that's where SSL brings in first encryption, but most importantly authentication, that we should know, the internet should know that the person pretending to be server Facebook is actually facebook.com, right? So somebody need to stamp that, hey, this server is actually Facebook, right? So those are called certificate authorities, right? CA is what we call. So on the right side, you see Gmail certificate. It is available through your web browser. So you see this global sign said it is GTS. GTS said, yeah, I know this server that you're trying to hit is Google, right? So this is how a certificate looks like. It has expiry. It has some issuer, which is CA, and all other details, right? We'll drill into this process, but most important thing is authentication, identification, that if I hit a URL of Facebook, then it should, internet should stamp that it is Facebook, right? So that's the value that SSL and TLS brings in. Now, as I said, authentication is the most important thing. SSL is being used. Encryption is later again. We'll see the process, why it is, how and why encryption becomes a second priority, right, after authentication. And the third is, since it is built on HTTP, HTTPS is by default is reliable, right? No packet gets dropped between client and server communication. So these are the three advantages and reasons why we use SSL and TLS, right? So one thing in this, in general terminology, right? SSL and TLS being often used interchangeably. It is fine to use, but there is a difference. Just understand that. And slowly you will see SSL will completely deprecated. Now we move on to the next level and talk about various terminologies, right? So often as soon as somebody asks what is the difference between digital certificate and digital signature, it seems very same. What is public key, private key? How is it stored? So we will talk about these scary terms. Typically, what I say, right? Some people say, what is TLS enable? What is key? What is the difference between key and certificate? Shared secret, negotiation. There are multiple terminologies which we'll try to ease through. So you should be comfortable after this session on using these terminologies. So scary term we'll explain through a handshake process of SSL, right? So SSL, as I said, HTTP had its own protocol. SSL just sits on top and says the way you initiate, the way you talk in HTTP, I'll just encrypt it. So there is a additional process in HTTPS which ensures that your HTTP is secure. Now, what is that process? This is called handshake process, SSL handshake process, right? So the way it initiates is, right, you start, you open your browser and you open Facebook, right? So you send a notification, your web browser, it becomes a client, and the server is Facebook server, right? So you say, hey, the first step, hey, I want any connection which is TLS enabled. Do you have anything? So, and these are the encryption suite that Chrome, the client supports, right? So it sends the information and hello message. Server responds back and say, hey, hi, this is my digital certificate, because you want to know in TLS, you want to know that, I am who I say, who I claim to be, right? So this is stamped by a digital certificate, right? So that contains name, CA, and public key. So just imagine a physical certificate, right? You get a lot of certificate of, let's say, AWS certification. So you will have your name, somebody stamping, and the specialty, you did this, right? So that's exactly what this is: name, CA's stamp, as well as public key. Now, in client side, there is a thing called trust store, which stores every known CA, certificate authority, right? And has a repository and list of it. And so client once get the digital certificate says, hey, your certificate is available in my repository. I know now who you are, and I know to extract your public key, right? So next step, client takes the public key and encrypts a certain random number, and that is called pre-master key. So don't get scared by this term. It is just a random number. Client starts and encrypts with the public key available and sends it there, right? And server again decrypts and gets the master key. Now this is being shared, right? This gets shared, and that's how both knows that the public key is correct. Now, so public key is correct, that means digital certificate was correct. Now once they establish this, they create a shared secret. This shared secret is just another key altogether, randomly generated key. This is often called session key or just a secret, right? So these terminologies are same. Don't get again phased by these, right? Session key, shared secret, and secret are just same thing. And the actual encryption in HTTP happens through this session key, not through public key, not through private key, right? So this is just a new key created for this session, and every time you hit a facebook.com, you will get a new session key, right? So even if any key get compromised, you are sure that it will still be encrypted because it is generated every time. Now once the shared secret key is agreed, this says, hey, I've done some encryption with the shared secret key. Is it fine? He said, yeah, it's fine. Over to you. Now we can establish connection. Now, so now the main transaction happens. Till now, it was just a handshake process. Now the main, your authentication, your DPs and all the data regarding you gets exchanged over internet, right? So handshake process just to agree on the session key, shared secret key, and it uses public and private key and digital certificates, right? Now, this first two processes are known as negotiation. So again, a new term for you, negotiation. Whenever somebody says, then, hey, I am using my public key and SSL process want to negotiate. So this is negotiation phase. In handshake process, one of a few steps are called negotiations, right? Now, till now it was more of a understanding and familiarizing few terms. Now we go into processes where developers or DevOps actually get to see things and do things. Now I'll quickly jump to one thing, right? So we talked about a trust store, right? So this is one of the screens, one of the list of in my Mac, it is a list of all the certificate authorities available. So every time a new Mac version comes or Chrome new version, Firefox new version comes, it will have a new set of CAs. And these CAs is what authorize Facebook and Google and any other URL say this is Facebook actually. This claims to be Facebook and this is actually Facebook, right? Now, how do you generate certificate? How do you get stamped from a CA, right? So now this is more of a technical thing. No, so if you have any query, you can just interrupt me in between, and of course I'll open up for questions. So there's a tool called OpenSSL, right? OpenSSL is savior. So how do you do it? On your machine, on the server for which you are trying to get a certificate, because you get a certificate for a domain IP or an organization name, right? So for that you need to log into the server and then run this command. So you are actually creating a CSR, certificate signing request, and then you create a private key. So OpenSSL helps you create a public private key infrastructure, right? Now you fill a form, and then you send the CSR, right? So CSR file will have so CSR means certificate signing request. This file will have public key and other information that you fill in the form, right? This whole platform, this whole standard of public private key, CSR, CA, this whole standard is basically called X509, which is a very scary term for you, and public key infrastructure. So somebody says X509 certificate, that means any certificate, any key which complies to this public private, this standard. That's all. Don't get again scared by this term. So by this time, using a simple command, a single command on your machine on the server, you actually get a CSR, public key, private key, and have created a certificate signing request. Now this is how it looks like on command. You run this command, the same command. You have to fill this form, India, and everything, and the email addresses, etc. And there are a few other things you can fill, but these are not mandatory. So you have filled all this information, and that's where you have CSR. So these two files will be created. .csr, .key. This is private key. So you keep that safely, very safely. There is a whole bunch of tools to keep it safe. And CSR. This CSR, you're going to send it to certificate authority to actually get that stamp that Facebook is who says it is Facebook, right? Now, this is how it looks like. The CSR, certificate request, this is how it looks like if you open it. And this is how a private key looks like. It is just a long password, very, very long password, right? In a simplistic term. Now, when you send the CSR to a certificate authority, so certificate authority is who? DigiSign, Global Sign, all these big players who have authority to actually stamp your CSR, right? So this is how it sees your CSR. When it opens up, it has certain details about your public key, the form details that you fill, right? Now this is what CSR CA gets and stamps it. Now how does this process happens? So CSR has CAs have many processes, like they can verify a domain, they can send you an email. Earlier it used to be physical verification, right? So that's how CSR is visualized. Now this is how the signing process looks like. So on a very condensed look, so you have created the CSR, right? It has all the information about the form that you filled and the public key. As I said, CSR has a public key and this information. We can see it again as well. This one, right? All the information and public key. It goes to CSR, and CSR has its own public and private key and a digital signature. What it does is it signs your CSR with a digital signature and encrypts that certificate with its private key, right? Now, it is just like an inception, and that's how the global chain of trust works. So there is a root CA who gives public private key to GTS, who can give authority to Google, right? There can be so this is called root CA. This is called intermediate CA. So a CA is also assigned public private key along with the digital signature, right? So this is how the chain. This is called trust chain in this cryptography. So in PKI, public key infrastructure. So a root CA gives authority to intermediate CA. Intermediate CA gives authority to your local CA probably, and local CA can give authority to can sign your SSL certificate, can sign your CSRs, right? So who CAs are? CAs are authorized set of organization who can sign SSL. This is list embedded in all the browsers. CA takes time and money, right? I mean, the whole process now it is very low. Earlier it used to be a long process. Like, I had seen a week at worst to get, and few hours at best over email. So that's the range it works. So it takes time and money, right? The whole process. So if you go to DigiSign, right? DigiSign to get a certificate, you can do the whole process of generating this. What OpenSSL does for you, you can do on their UI, right? So you get signed certificate. So that is your SSL certificate. That is Facebook's SSL certificate. As I showed you, this list of CA is in your machine, in your browser. Every browser maintains its own. So anytime a new CA comes up, root CA gives authority to intermediate CA. That intermediate CA will come in here, right? So this is the process now, right? What you have to do as a developer or DevOps. So what next? Add this certificate, right? Typically it is in PEM form, .PEM, right? So this certificate you have to add in your web server, load balancers, wherever you want to, have that SSL capabilities. Keep private key always secret, right? Now I'll just talk about this key store, right? Key store, the store which actually manages and stores all the private key, and we'll talk about it briefly in next few slides. So you have to keep your private keys private. SSL are mostly in PM or sometimes CRT format, right? So whenever you see a PM key, you should assume that this is a signed, mostly, not to be confused with SSH keys, which is also PEM format, but not SSL keys. SSL certificate. So whenever you would have heard about my SSL expired, this is the most frequent thing we get, right? So you have the private key. You can generate a new CSR with the same private key, and then send it for signing renewal. There are, so if you go to DigiCert website, it will know that, hey, I issued you a certificate. Just hit the renew button, pay me money. I will give you a new certificate. That's also possible. So yeah. So all that's said and done. Good. Now, but there are two problems, right? First, CAs take a lot of time and money to actually sign your request. You want to avoid open source and everything coming up. Everybody wants free SSLs, right? And if you are doing any hobby project, right, your organization would not issue you a SSL, won't spend that much, right? What to do in that cases, right? And if you have an intranet, a lab and only a private cloud talking to each other, then you don't need a CA to be stamping on that, right? So how do you? But the browser says, hey, stamp your certificate without CAs, I won't accept. So in that cases, what you do, in your local infrastructure, in your local projects, and want to save money, right? Now, these are the tools that we'll do. So remember this command, right? There was we used this to create a CSR and key. Now, just add one more flag, X509, and you create a self-signed certificate. That means self-signed certificate would mean that I know, so I am signing, no CA signing here, but I am signing my certificate myself. I'm stamping that, hey, it's me, Manish, right? But most of the browser do not accept it. There was a time, if you use that self-signed certificate, then you see this error message, right? And if you remember, just a few years back, browser used to allow, if you hit advanced and you go to, take me to, I understand the rest, take me to website irrespective. But what browsers realized is, though most of the cases you might know this is a self-signed certificate, but this is a backdoor entry for hackers, right? So they stopped it. And now no more in the new browsers you see this option, right? So self-signed certificate, which is one of the example is here, right? So the same CSR which we saw earlier, if self-signed, then it has validity, it has issuer, etc., right? Now see the issuer details. It is same as my subject details. So this is how we know it is self-signed, right? It has validity of 1 month only. So Now, so take me to website. I know the risk is gone. Now the way you can now work around that is create your own CA. Now earlier you used to create your own certificate by self-signing it. Now create your own CA in local machine and say on every device for intranet, on every device which is using, I will add this newly created CA and say it is stamped by this CA. So my self-signed certificate would work, right? But there are too many steps involved, and there if you are generating a local CA, signing your self-signed certificate with that local CA, and you have to go and install the CA to every browser and every device, right? That's a little complex. Now there are other tools which helps you in that. Let's Encrypt, right? So Let's Encrypt is just like a CA, just like what you saw Google, right? And it provides you a certificate for free for 90 days. Other CAs provide for 1 year mostly, but Let's Encrypt is a certificate authority which provides you free. That will sign with your CSR. It provides you as a certificate for free for 90 days, right? Now this is just a open source phenomenon that will pick up. That is picking up, and everybody in the shops like DigiCert will actually, I think, in future will stop, and everybody will move to Let's Encrypt. So Let's Encrypt is a CA. How do you generate? Just like OpenSSL, in OpenSSL we created CSR, public key, private key, and then sent a CSR. You talk to Let's Encrypt using some tools. One of the top tool is certbot. So you have to have certbot and write some commands, and you will have a signed certificate automatically. That's all, right? No need to spend time and money. So the way Let's Encrypt actually does this whole process is just say, send me an email where I'll where I'll validate that you are the person who is sending, or in your Route 53 entry or GoDaddy console, just add a random string so that I will know that it's actually you who's requesting, right? It's actually you, Facebook. So there are some short way to validate any domain. Let's Encrypt use, and that is also through certbot, right? So have certbot, talk to Let's Encrypt, get your SSL for production systems. That's the best way these days, free of cost you can do, right? Now there are some complex just details. There's a new protocol so that certbot actually can talk to Let's Encrypt. This is Acme protocol. This makes sure that it is the same person who actually is claiming it to be, right? This is one of the way Let's Encrypt ensures that your authentication. Use case, as I said, for production system. Let's Encrypt can be used for production system. Many websites use that. Let's say, I forgot the name. Many design, many top website actually uses them, right? So Mashable is one of the things. Mashable is one. But there's a problem still, right? As a local developer on your machine, if you're talking to SSL only a website endpoint, how do you solve, right? Let's Encrypt, either you go and do the Let's Encrypt, but that time you don't have you don't have a domain name for which you will register certbot and get a SSL, because it's your local host. So now you need a local CA, for this problem, for the last problem, you need a local CA who can help you, right? Who can generate a CA and a certificate for a local host, let's say 443, localhost 443, right? Now comes make certificate. So here you see, TechRadar is another one. Yeah, TechRadar, Mashable, as I said. So Let's Encrypt is same as other CAs, and yeah. Make certificate. So now to create a local CA, right? So make certificate. Just with 2 commands, you can create a local CA, and you don't have to go to CA authorizing it, right? So your local CA can actually stamp that the certificate generated on this machine belongs to this local host, and your local web browser. On the bottom, if you see local web browser will actually identify localhost, and it will always give you this padlock rather than the red triangle or some problems. So Make certificate should be your go-to tool for any SSL related things on while you develop, right? We use it internally for Portus and Git hashton.com. So again, this again is going towards supporting Let's Encrypt, so that Let's Encrypt actually can can have your own CA, have that Let's Encrypt CA in your, right? So we talked about two commands through which you can actually use make certificate. So make certificate, this command, localhost and website, anything that you want to, any DNS you want to type with that server, right? It gives you PEM file, which is certificate. You just install that certificate in your trust store, so that this command actually sends this PEM file, this CA, the local CA that you created, in the trust store, so that your local web browsers know that the certificate is now genuine and don't give you that red triangle. So all said and done, right? Just to summarize everything, and you probably talk about few new terms which we just want to touch upon, don't want to dwell in. For local development, use where only your local browser is a client, use make certificate for local CA and add CA in the local web browser by using these two commands that previously we used. For production systems, right, use Let's Encrypt, create all the certificate, and tie that Let's Encrypt with the DNS that you want, like let's say hashton.com or facebook.com, right? How do you refresh? How do you auto renew? Because as I said, 3 months is the validity. You can use, many tools are being developed, but simplest job, probably 6 months back, we used to just have a cron job running on the server who would send who would use a certbot command to auto renew, and it would run weekly, so that as soon as you're near expiring your certificate, you can renew that, right? Now looking at Let's Encrypt, there are many CAs who have created their certificate management, but says my certificate will only work with certain services. AWS has a certificate managers, right? ACM is what we call it. It is same as Let's Encrypt, but it is only used for AWS services, right? AWS services mean when you need any AWS services to talk on HTTPS, then you install that certificate, right? Private and local entities should be safe and managed. So now we talked about keep your private key private, right? And I got this request at the start when this session was planned, that what is key tool and key store, right? So key store is where all your private keys are safely stored. In another, you would have heard about key management systems, KMS, and key vaults, and key stores. So basically all these things does the same job of managing and keeping your private key safe, right? And the way you talk to them is key tools. Now Java key tools, etc., there are multiple tools available. The way you talk to key store is key tool. Now this key store is often confused with another term, which is trust store. We talked about that. There is a list of all the CAs that we have, right? Now that mostly is managed by trust third-party tool. Now, as I said, whenever you update your browser, you get you actually updating your trust store. You can manually go and update your trust store, but mostly is managed by third-party tools. But key store, because it's your identity, you rely on some tools like key tools to actually update and manage your private keys, right? But mostly for developers, just keep these two things in mind, and it should be good. You are good to go, and I believe that you understood the concept completely.